3G and 3H, transformations of powers and finding the rule. Today we're learning about transforming power functions and finding the rule of various functions. What you need to be able to do is sketch various power functions with transformations, find the equation of a function given transformations applied, and find the equation of a function given points that lie on the graph itself. So example 15 says find the sequence of transformations that takes the graph of y equals x to the 5 to y equals 6 minus 2 x plus 5 all to the power of 5. Now you'll notice this is exactly the same as everything we've already been doing. I guess it's specifically in this exercise because it's about powers, so we're talking about the power of 5, but really it's all the same as always. So whatever we start doing, remember with our new function, we just put in the dashes so we know that that is the transformed function. And then we can go through our steps. So the first step is to get all the y's on one side, all the x's on the other. So remember, anything that is outside of the bracket that is bound with x needs to go over to the other side. So everything that's attached to the x stays, everything else is for the y. So that's a positive 6 will become negative when I take it over, and then divide by negative 2. And we've got this to the power of 5. All right, our second step is to equate the y's and equate the x's. Remember, you don't need to write the power of 5 because it's the same. We're looking at just what's happened to x itself. Step 3 is to rearrange to get x dash and y dash by itself so that we can actually see what has happened to old x and old y. So how did I get from old x to the new one? We can then figure out the order of our transformations. Remember, our transformations happen kind of like BODMAS. Whatever is closest to the x and the y goes first. So we've got a dilation, a reflection, and then we've got two transformations. I can just clump them into one because transformations can happen at the same time. All right, now we can go ahead and write it out. Wasn't a very neat line. We can try that again. All right, so for step 4, I'm going to go ahead and write out my transformations. So first we've got a dilation of factor 2. Now because it's affecting the y values, it's going to be from the x-axis, so it's moving away from the x-axis. Then we've got a reflection, again affecting the y value, so we say in the x-axis. And finally, we can talk about our translation, 6 units up and 5 units to the left. All right, now that's the dash method. Of course, if you were able to just look at the function and see it, and in this case, I would say this is a very straightforward function, you can actually come up with these 3 transformations in the exact same way. So remember, your order is always DRT, dilations, reflections, translations. If there's anything in front of the x, you need to factorize it out. In this case, there isn't, so there's not much that we need to worry about here. Okay, so if we have a look at our transformations just by reading it off, firstly, I can see that there's a dilation here too from the x-axis. So because it's outside of the bracket, then it's going to affect my y values. So anything that's outside affects my y. Same with this negative, that is going to be a reflection in the x-axis because it's on the outside of x, it affects the y values. Finally, I can see that there's a plus 6 on the outside. Again, on the outside means affects the y value, so we're going to go 6 units up. And we've also got a plus 5 that is attached to the x. Now remember, with x, the sign is always the opposite. So if it's a plus 5, we're going to move to the left, not to the right, like I just drew. We will be moving in the opposite direction of what we would anticipate. So think of it as going 5 to the left. All right, and if you'll notice that everything that we just said is actually everything that we found with the dash method. So it's up to you, whichever one you want to choose, whichever you're more comfortable with. I would say this is a relatively easy equation, but of course there are more equations that get more tricky that will require you to do the dash method itself. Okay, so then moving on, we're going to now think about determining the rule. So what you'll notice is this is actually things that you've already done before. It's a lot of just substitution. So the idea of determining the rule, it means to find the unknown values of a function. To do this, you should always consider any special points that could be filled in filled in right away. So like asymptotes, turning points, your H and K points. Consider any other points. Each unknown requires 1 point that has been given. So for every unknown, you need a point. Basically, we're going to substitute all the values in and solve, and then just check over it at the end, just to making sure everything makes sense. So our examples from 3H are as follows. So the first one says the points 1, 5, and 4, 2 lie on a curve with the equation y equals a on x plus b. Find the values of a and b. Now, unfortunately, neither of these are special points, so we're going to have to just do our classic substitution. There's 2 unknowns, therefore I need 2 points. Now this is point 1, remembering that this is the value of x and y, and that can just be substituted in. So I'm just going to label that as point 1 and 2. So when I sub in point 1, I'll get 5 is equal to a on 1 plus b. When I simplify that, that'll be 5 equals a plus b. When I do point 2, I'll get 2 is equal to a on 4 plus b. Now, to simplify this, couple of ways to do it. When I'm thinking about substitution, I want to try and isolate a variable. So if I can take the b over to the other side and then multiply the 4 over. So take the b over, multiply the 4, I can get a by itself. What that enables me to do is to substitute that directly into there. So now I'm going to sub 2 into 1. So we'll get 5 is equal to 4, 2 minus b equals b, plus b. And then I just need to solve, essentially. To do that, I'm going to start by expanding. I could take the 8 over, so 5 minus 8 is -3, and -4 plus b is -3. And that's really nice because the -3 divided by 3 is simply 1. And then I can sub b into, doesn't matter which one, but into 2 will be easier because I've already isolated a. So a is equal to 4, 2 minus 1. 2 minus 1 is just 1. So that's really nice. We'll get a is equal to 4. So there's b is equal to 1 and a is equal to 4. All right, last example. It says the graph shown has this particular rule. Find the values of a, b, and b. Little b, big B. So we can see that we've actually got two special points here. So these two values, little b and big B, are actually the asymptotes of this hyperbola. So that's recognizing that that would just simply be this here. Now we can see that because we've moved to the right by 1, remember whenever we put it into the x, it's always the opposite sign. So in this case, b will have to equal to -1 so that we can indicate that it's gone to the right. However, with y, it stays as it is, so that will just simply be 2 because I need to take the whole graph up by 2. Now to find a, what you need to do is just substitute in another point. So far I've got x minus 1 plus 2, and I'm just going to sub in the point 0, 1, and we'll solve from there. So I'll take the 2 over, 1 minus 2 is -1 on a -1, and then that's just as simple now as -1 times 1, which is +1. So we have our final value, which is a is equal to 1. All right, that's it for chapter 3. Good luck with your tests coming up.